Okay, so looking at the final review, again, everything here deals with skills we dealt with. There are a few questions that might slightly go away from things that we had already done, but there'll be combination of skills we already used and just saying like, hey, this is how we put them together. So a ladder, a 15-foot ladder reaches 12 feet up the side of the building. What's the angle it makes with the ground and how far is the ladder from the building? So here we got two pieces we're solving for. Let's just start with drawing it. Here's our building. And here is the ladder. Okay. So I know that the ladder is 15 feet. And I know that it reaches up 12 feet. So that would be my opposite. Because I want to know the angle it makes with my ground. I can put theta there. Here's my hypotenuse. And then this would make this unknown side, I can call that x, my adjacent. Well, first thing we're going to need here is that angle. So we're going to do this just like number 4 from the quiz yesterday. So I have opposite and hypotenuse. Opposite and hypotenuse. So yeah, that's sine. So I can say the sine of theta is equal to my opposite, which is 12, over my hypotenuse, which is 15. Now, since it's sine, that means I do the inverse of sine. So I do sine -1. So my angle theta is equal to sine inverse of 12 over 15. This just goes in the calculator now. So let's make sure, okay, we got Desmos open. Let's double check we are in degrees. Yes, we are. So functions, sine inverse of 12 over 15 gives me 53.13. That's what the angle is. So the angle is 53.13. Now that I know that, I can use whatever function I want to get, or actually not whatever function I want. I can use either cosine or tangent to get my adjacent side. Because now I know this angle is 53.13. Let's see, I'm going to just utilize opposite over adjacent. I don't like that. I like to do adjacent over hypotenuse, put my variable up top. So I can then say that the tangent of 53.13 is equal to my adjacent side, x, over my hypotenuse of 15. Now I'm just going to solve this. I'm going to multiply both sides by 15. And we get x equals 15 times the tangent of 53.13. Let's go ahead and type that into the calculator and see what we get. 15 times the tangent of 53.13. And, oh, not the tangent. Sorry. Whatever. It's early in the morning. Let's restart that one. I'm not using tangent. I meant to use cosine there. That was 100% on me. Tangent would be opposite over adjacent. I did adjacent over hypotenuse, so that's cosine. So let's rewrite that. Cosine of 53.13 is equal to my adjacent of x over my hypotenuse of 15. Now I multiplied both sides by 15. I'm so sorry about that, guys. We get x equals 15 times the cosine of 53.13. Now we're going to put this in the calculator being cosine. So cosine there gives me 9.00. I'll just go and call it 9. So I get the x is equal to 9 there. So that's the first problem. Number 2 is going to be incredibly similar to this. So again, I am going to be posting the completed notes as we go, and I will be posting this lesson as well. So hopefully you got this down. Let's go on to number 3. Number 3 is again one of those, we dealt with quadratics. We know essentially what to do here, but it is a little different than what we've been doing. So a football player kicks a football. The height of the ball is given by the following equation, where t is the time in seconds and h of t is the height of the football. So what is the initial height of the football? It says, show or explain how you got your answer. So with this, the initial height of this is always really easy. The initial height's whatever's added on the end. So whatever your C value is, that's like your starting height. So what's the initial height? The initial height is 3 feet. As that was the unit we were told we're using, 3 feet. That is the C value. What time does the ball reach its maximum height? Now, finding the max, we didn't formally go over this, but luckily it's pretty easy to do on Desmond's. So what I'm going to do is I'm going to graph this equation, and I'm just going to find where the max is. So this said h of t is equal to negative 16t squared plus 85t plus 3. So now I can't fully see where the top is, so I'm going to work on zooming out. I'm going to zoom out this way by just making my y-axis bigger. Let's see if I get up to 50. Can I see the top? Nope, not just yet. Let's try 70. Oh, almost there. Let's go with 80. Let's go with 120. There we go. So now I can see the top of this graph, right? Literally, all you have to do is click on the maximum. That's where it is. Now, what would make sense here more for the time? If I'm kicking a football, does a time of 2.6 seconds make more sense? Or does a time of 115 seconds make more sense here? How long is the football in the air? If I throw a football, is it coming down quick or is it staying in the air a long time? Yeah, so 2 seconds makes more sense then like over 100 seconds in the air, right? I'll get your stuff in a minute. So the 2.65 is the time. So what time does that reach it after 2.65 seconds? And how did we get that? We found the max on the graph. Now, for the maximum height, if I were kicking a football, say a football, okay, I kicked it up in the air and it goes up 100-something feet, that makes more sense than like it only went up 2 feet in the air, right? So again, looking here, using a little bit of common sense, oh, it makes a lot more sense that that 115 is how high the ball goes up in the air. So that's 115.89 feet. So what's the maximum height of the ball? 115.89 feet. Again, found the max on the graph. Now, let's see, when does the ball reach ground level? So looking at this, the x-axis is going to be where we reach the ground. So that's all I'm going to do is click on that. So I click on this and it gives me a time when we reach the x-axis of 5.35 seconds. So the ball's in the air for just a little more than 5 seconds. So that's a pretty good kick there. So again, I just found that by looking at those. So that was 5.3, what was it, 5 seconds? Yep. You could have done the quadratic formula on this to get this as well. But I'm going to just say you found the 0 on the graph. So that is number 3. Look at how much time I took. I'm just going to stop right here. We'll pick up with number 5 tomorrow. I want to give you guys time to work. If we took the time to do the quadratic formula on this, I'm going to very quickly do that here. Again, we'll get that same result. So remember, the quadratic formula says negative b, which was 85, plus the square root of b squared minus 4 times my a value of negative 16 times my c value of 3 all over 2 times negative 16. Okay, the first one with the plus gave me a negative answer. Negative time doesn't make much sense, does it? That's before you kick the ball. I'm not worried about that. So what I'm going to do then is copy that. And I'm going to flip this from a plus to a minus. And again, that's giving me that same number as where it crosses here. So that is what I have for today. We'll pick up the other problems tomorrow. This is being recorded, so that will be posted later today as well. Stop recording. Yes.